Good afternoon. This is a presentation for our solution for the Robothon competition 2022. We will first do a quick introduction, go over the equipment and setup. Afterwards, I'll explain the implementation and the solution, and lastly talk about our impact on e-waste handling. We are Team WasteHandlerX. We come from a variety of different backgrounds within Accenture, but all share the interest in robotics and all work in industrial R&D and consulting. This challenge perfectly aligns with Accenture's ideals of sustainability, at the same time providing us a platform to bring roboticists and training together under one common goal. The team is spread all across Europe. In Munich, we have Enrique and Fabian. In Sofia, we have Hugo. And in Cluj, Romania, we have Cosmos. For our setup, we have chose to work with a Panda arm with the standard grippers, and we had it available in both Sofia and Munich. For perception, we are using a D435 camera from Intel. Our main site is Munich, where the task force is also located, but due to previous collaboration within Accenture and the Robothon organization, we have access to one task force in Sofia that Hugo used to also have some hands-on experience testing with the board. For the implementation, we have went with a frame of reference approach. This means that all interactions for all tasks are created in a fixed frame of reference with the translations rotations in relationship to the base link of the Panda arm, as you can see in the upper right image. Then the perception node that utilizes OpenCV and PyRealSense analyzes the board and changes the transform to the updated version. All tests then utilize this new board frame as a base to perform all movements. The manipulation tasks use MoveIt to perform tasks such as basic movements and Cartesian planning. We also created some custom algorithms to perform tasks such as force feedback interactions and also spiral searching. Now for the tasks themselves. In the first task, the perception node detects the board using contouring, finds and filters the corners using circle fitting and k-means clustering, and lastly extracts the rotation and translation of the board to create a new frame of reference. As for pressing the button, the arm first moves above a fixed position in the world frame to pick up a sponge cube. It then moves above the blue button in board frame and presses down until the fourth threshold is reached. Once the button is pressed, it then places the sponge cube in its original position. Task 2, key insertion. Here, the robot first moves above the key and grasps it from the keyhole. It then moves above the secondary location and tries to one-shot place it by moving downwards in a z direction until a fourth threshold is reached. If that fails, the robot will perform a spiral search around the center point to look for a downwards motion that would not breach the fourth threshold. Once the key is inserted, the arm twists it by 45 degrees. Task 3 follows the same logic as Task 2. So first, the Panda arm starts by gripping the Ethernet cable out of the plug and move above the secondary position. It first attempts to one-shot place it by moving down in the Z direction, but if that fails, it will perform a spiral search to look for a better position to move downwards. Once the plug is inserted in, the arm moves away. Task 4. Task 4 consists of three main routines. The first one, the robot moves above the battery case and opens it by applying a motion in the negative Y direction of the reference frame. After grasping and putting it away, the robot moves to the second and third routine. It utilizes grabs to force the batteries out of the case and then picks them up in a diagonal pose. Afterwards, it moves the battery to a pose above the hole, releases them, and moves above them to press them down to enact the button inside. Task 5. Extracting the coin battery. We have created the walkthrough, but due to time constraints, we cannot fully integrate it into our presentation. It would be structured as follows. The robot would utilize its gripper, tilted by 45 degrees, to press the release mechanism of the battery by applying enough force for the battery that it releases upward, but remains in the battery due to the constraints of the gripper. The gripper would then approach it from above and grasp the coin battery using a tilted pose and release the battery onto the case. Lastly, in task 6, we would use the same logic as in task 1 and press the button with the sponge cube. But what is our impact on e-waste handling? Our approach is focused around using a reference frame of the board, and this enables us to work across multiple sites on the same issue, to reuse poses captured in Sofia in another place like Munich, and to quickly deploy and test these different implementations without any need for changes. By taking part in this competition, we have raised awareness internally within Accenture for e-waste handling, and also got a better understanding of the barriers and requirements that we need to tackle in this issue. We are therefore better prepared for further developments in this area. Thanks a lot for your attention. This has been our presentation for the Robothon Grand Challenge 2022.